Okay, all right. So before we get started, I've had a few offline doubts on, not doubts, questions on extra material and all that. So I'll suggest a good book from Art of Problem Solving after the class. So it's a good book to invest in to supplement whatever you're learning here. Okay, before we discuss homework 3, any overall questions from last time? Any specific bothering questions from anyone? Arav, Vyom? Sorry, I call you Vyom. Yuom, right? Yuom or Vyom? How do I call you?
Yuvam.
Yuom. Any questions, guys? All okay? Yuom, you had a few doubts. Those were from the homework only, right? Specifically from the homework. Is that right, Yuom?
Yeah.
I cannot hear you if you're saying something.
Yeah.
I'm just
Yeah.
seeing.
Can
Okay,
you
yeah.
hear me?
Okay, guys, whenever you respond, please unmute. Take time to just respond to me and then mute yourself. If you're just unmuting and then quickly just saying something, I cannot hear you. Not just for Vyom, for everyone. Okay. All right. So if there's no questions, let's dive into the homework discussion. All of you bring up your homework 3. And yeah, so don't worry if you're not able to do a lot of these questions in the homework. They're intentionally hard. But at the same time, I want you guys to have spent enough time trying it. It's not like you look at it and say it's hard and then leave it, right? If you have spent enough time pouring through it, even if you didn't get it, as part of the discussion, the learning will be complete, right? On the other hand, if you just glance through it for 10 seconds and said, oh, I have no clue, and then move on, then it's not worth it. Anyway, so let's discuss. First one, by doubling the number of sides, new polygon has 6 times as many diagonals. Okay, all right. Sanvi, what did you get on this one? Find the ratio. What is the ratio you got, Sanvi?
I was getting it in decimals. I'm not really sure how to do it.
Decimals, okay. Even if it's decimals, can you call out what did you get? Even if, I mean, ratio can be decimals, right? Sorry.
I tore the page and threw it.
Oh, okay. Yeah, don't do that, right? So how else will you know what your mistake is? Yeah, but always, okay, that's another good point, right? Even if you have some wrong answers or weird answers, just save it, right? Later, maybe you should also know what is wrong in it, right? If you're able to figure out what's wrong, that's great. If you're not able to find out what's wrong, then obviously the learning is not complete. So you should ask. Okay, yeah, Suhani, I see your hand up. Yeah, go ahead.
Oh, yeah, I wasn't sure about the question, but I got 5:2, but I don't know, like for certain if that's correct.
5:2. Okay, any other answers matching? Veer, what did you get?
So I couldn't figure this one out.
Sir,
Okay.
I got the same answer as Suhani.
5:2 as well. Okay, all right, good. So if 2 people got same, very likely it's right.
I got the same as well.
Same. Okay, cool, nice. So let's do this. By doubling the number of sides in a regular polygon. Okay, regular polygon. What is a regular polygon? A polygon which has all the side lengths same and all the angles are same. I should mention both, right? For a triangle, an equilateral triangle is regular because the sides are equal and the angles are also equal. For a quadrilateral, you cannot say a rhombus is irregular. Even though all the sides are equal, the angles are not equal. Likewise, you cannot say a rectangle is irregular because all the angles are equal, but the sides are not equal. So neither of them is regular as far as quadrilaterals is concerned, right? The quadrilateral, which is regular, is a square, which has both the sides and the angles are equal. So for a general polygon, the sides must be equal, the angles must be equal for it to be regular. Okay, now, what do we say here? By doubling the number of sides in a regular polygon P, okay, let's say in P, the number of sides is n. Okay, so in Q, the number of sides is 2n. Right, in a new polygon Q. New polygon Q has 6 times as many diagonals. What is the formula for the number of diagonals for an n-sided polygon? We derived it last time. N times n minus 3 divided by 2. Just to recap where we are getting it from. Let's say I have a big polygon like this with some n number of sides, doesn't matter. From each vertex, I cannot draw a diagonal to this neighbor, and to itself. But to every other n minus 3 vertices, I can draw a diagonal. Okay, and then each vertex will count likewise, but then each diagonal gets counted twice, right? And therefore, it's divided by 2 to avoid double counting. So the number of diagonals in this case the diagonals in this case would be just n into n minus 3 by 2. Whereas in this case, where the sides are doubled, the count of sides is doubled, not the right. The number of sides is doubled, not the side length. So it's 2n times, instead of n, it's 2n. That's it. So 2n times 2n minus 3 by 2. And the relation between these two is that this guy, the lower guy, is 6 times the previous guy. Okay, so let's write it out. So 6 times n minus 3 divided by 2 is your 2n times 2n minus 3 divided by 2. So it's just simplification from here on, right? So 2 cancels, n cancels, giving 3. So I have 3n minus 9 equal to 2n minus 3. Therefore, n equal to 6. But that's the answer. N, so far we have discovered only the number of sides. Veer, you're okay so far? Till this part, you're okay? Veer. Okay, he's having trouble unmuting.
So can you hear me?
I cannot hear you if you're saying something, Veer.
Can you hear me now?
I can see you're unmuted, but are you asking something?
No, sir. I was just saying that I've got it so far.
Oh, so far is okay, right? Okay, good. So we have 6 sides here and 12 sides here. So 6-sided polygon, let's verify quickly. So for a 6, even though we have done our calculations here. So for a 6-sided polygon, 6 into 6 minus 3 divided by 2 is the number of diagonals. How much is this? 9. For a 12-sided polygon, because when you double the number of sides, it's 12 into 9 divided by 2, which is 54. So sure enough, 9 times 6 is 54. So we have checked that so far things are good. What is the ratio of internal angle in Q to external angle in P? Okay, so what is each internal angle? The sum of all the internal angles. So internal angles, the sum is 180 times n minus 2. Okay, so for the smaller polygon, I'm asking what? Okay, for the bigger polygon, okay, you should be careful, right? Internal angle in the bigger polygon, right? So for the bigger polygon, the sum of all the internal angles is 180 times n minus 2. N is the number of sides, but in this case, the number of sides is 12, right? So it's 12 minus 2, therefore this, and that's the sum for all the internal angles. Each would be divided by the number of sides. Each would be divided by 12, right? So that's the internal angle in Q. And what's the external angle in P? External angle in P. Sum of all external angles is 360. So irrespective of whether it has 100 sides or 23 sides, the sum of all the external angles will be 360 for any polygon. But because it's regular, each will be divided by 12. The division is possible only if it's a regular polygon, right? So this is 360 divided by number of sides in this case was 6. Okay, so it's this ratio that we want. Okay, so how much is this? This is 150 is to 60. Yeah, which is indeed right. 30 times 5, 30 times 2. So well done. Yuvam and Suhani and whoever else. Ranveer, was that you who got the same answer you said? I forget who, Arav maybe. Okay. All right. Clear. For whoever didn't get this, is this clear? Sanvi, you're okay on this?
Yes, I did the same thing. I think I made a calculation error.
Okay. You got till the number of sides, or the calculation error happened after finding the number of sides or before?
No, so I got the number of sides and then I made a calculation.
You made a mistake after that. Okay, sounds good. Okay, so overall straightforward question. If you just follow along the ask, right? Okay, question 2. A, B, C, D, E, F, G, H, I think. A, B, C, D, E, F, G is a regular heptagon. Heptagon, also known as septagon, which is 7-sided, non-regular. Okay, non-regular meaning whatever, like it's not regular. It's similar to another septagon or heptagon, which is 7-sided again. Now AC is 3 times PR. Okay, let's draw this septagon. So how will this septagon look like? Let's say I'm randomly drawing something. Let's say this A, B, C, D, E, F, G. Okay. Okay, all right. Maybe I'd do Okay, so here I have to accommodate 3 more, right? A, B, C, D, E, F, okay, G, then back to A, something like this. Okay, so this is a non-regular heptagon. Now this is similar to another PQRSTUV. So I'll just draw, which is AC is 3 times PR. So this is going to be a smaller one. So the same shape. Again, you don't have to draw all this. I'm just taking time to draw so that you guys are following. So I'll just draw a similar shape. Okay, so similar shape. P starts here, P, Q, R, S, T, U, V. Okay, now AC is 3 times PR. So where is PR? So let me mark PR here. And let me mark PR, let me mark AC here. Okay, you can see that they are corresponding sides, meaning they're not same in length, but they correspond to the equivalent points in the 2 pictures. Okay, once this happens, so we can use similarity, right? So similarity, they are given to be similar. So if you have similarity, then what do we know? We know that anything that is in a linear dimension means anything which is talking about any length will be in the same ratio as the scale factor. So in this case, the scale factor is, you can write k is to 1 or 1 is to k, it doesn't matter. In this case, it's 3 is to 1, right? So the larger one is 3 times the smaller one. So AC is 3 times the smaller one. I've given AC and PR because they are corresponding lengths, like I said, right? So any linear ratio will be in the ratio 3 is to 1. Any area will be in the ratio 3 square is to 1 square. Any volume ratio will be in the ratio 3 cubed is to 1 cube. Okay, now what is the first question? Find the ratio of the areas of triangle QTV to triangle BEG. QTV to BEG. So QTV will be a triangle like this. QTV is this triangle. Okay, I should have used a different color because it's corresponding to blue, but that's fine. QTV and BEG is the corresponding triangle here. BEG here. Sorry, I should have waited to ask what answers did you get. Arav, did you get an answer on this one?
So I got 9 to 1.
1 to 9. You have it right, but intentionally I've given QTV to BEG. So the smaller is to larger. While the scale factor is 3 is to 1, looking larger to smaller, the question is asking smaller to larger. Therefore, it's 1 is to 9.
Oh, yes.
Makes sense.
Yeah.
Okay, so fairly straightforward. 1 is to 9. Find the ratio of the perimeters of the circumcircles of triangle ADG and PSV. Again, same thing, ADG. So I'll just mark the A, D, and G are here. Where are the corresponding PS and V? P, S, and V are here. They are corresponding points. That's all matters. As far as the ratio is concerned, all the dimensions do not matter at all. So the perimeters, because it's linear, it's 3 is to 1 or 1 is to 3, depending on which direction you're looking at. It's the larger is to smaller in this case. Therefore, it'll be 3 is to 1 as well. Does it make sense? So even though on the surface of it, the problem looks very complicated, heptagon, circumcircle, this, that, and all this, right? Ultimately, it's just scale factor or scale factor square, or potentially, if you have a 3-dimensional object, it's scale factor cube. All of you good on this? Whose video is off? I can only see a name. I don't know who that is. It says Samsung something. Who's on with the laptop, please? Veer, your video is off, by the way. Okay, now it's on. Someone else is on with the video off. I don't know who that is. Okay, Yuvam, you had a doubt?
Yeah, so how is the triangle's ratio 3 is to 1? Because is it because it's linear?
Yes. So ratio for the second part, is it? Or
Second part, yeah.
yeah. So perimeters of circumcircles of triangle. So there are some triangles. Let's say I have a triangle, and there'll be a circumcircle around it. But I'm asking perimeter, which is a length. Ultimately, it's some length versus a corresponding length. That's all. Therefore, it's linear.
Yeah, because it doesn't contain any area or volume.
Exactly. Yes. Yes. I need to know whoever is on using this device without the video. Either you have to call out your name or I'm going to remove you from the class. Whoever this is. Can someone call out whose video is off? Samsung device, SM something something. Okay, I'll since no one is calling out, I'll remove this person, and then you have to rejoin whoever that is. Okay, I'm not able to. Okay, all right.
So why is in the second question, like the first bit, why is it 1:9? It's not the volume, it's the area, right?
Yeah, and therefore it's 1:9. If it's volume, it'll be 1:27. 3 square is 9, right?
Yeah, wait. So we're not like calculating anything, we're just using like this 3 square is to 1 square and assuming that it's
That's it. No, we are not assuming. That is the reality. Ratio of areas will be the scale factor square. The scale factor is 3:1. Therefore, the area will be 9:1. 3 square is to 1 square, in other words.
okay, thank you.
Sure, you don't seem convinced. You're okay?
Yeah.
Okay, yeah, it's 3 square is 9, right? So I still didn't fully understand. As far as looking at area ratios, it's 3 k square, where k is the ratio. Okay. Okay, good. That's question 2. Question 3. Center did you approach this question?
So I had a doubt on this. I have no clue.
Okay. Arya, what about you?
Yeah, I didn't get this one either.
Okay. The first part should have been okay, right? If P is find P, if it's given to be the fourth quadrant. Did anyone get it? Ranveer, did you get an answer for 3A? Suhani? Anyone with an answer for 3A? Veer? No? Okay, let's discuss. Okay, so circle with center P cuts the x-axis at 2, 0 and 12, 0. Okay, so let's draw a circle.
Oh, sorry. So for this one, I just took the average points of the X and Y.
Average points of x and y to find the
To
what?
P.
So which will be you mean 7, 0. Is that what you mean?
Yeah.
Okay. Okay, let's draw a circle. Okay. Now this is x-axis. Sorry, should have drawn it here. Okay, and I'll draw x-axis, y-axis here. Okay, so sorry, it does not cut the x-axis. It cuts the x-axis at 12, 0 and 2, 0, right? So the x-axis is more like this. Okay, and the y-axis is something like this, let's say. Okay, so we have drawn a diagram. Now this is 2, 0. And this is 12, 0. Sorry, someone is pinging me. Is it Drishit? Oh, sorry. Okay, it was actually Drishit. His mom had messaged me saying he'll join. Please. Just 1 second. His mom had messaged me that he's not well and he's going to keep his video off. I completely forgot. So now I realize that's the one I have removed from the group. Just 1 second. So sorry, guys, my bad. See, actually, the mom had actually said that Drishit is not well and he'll keep his video off, but I had forgotten that. Anyway, so let's back to the question. So 2, 0 and 12, 0 are the intersection points with the x-axis. And then find P if it's to be in the P is the center, right? So let's mark P here. So P is the center here. Okay, so these two are the points where it cuts the y-axis. Now, what do we know? We know an important property in circles. So we saw that if there are two chords which are intersecting inside the circle, let's say it's AB and CD like this, and let's say the intersection point is M, then we saw AM times MB is CM times MD. Okay, and then we also saw that this is true even if the intersection point is outside the circle. Let's say this is AB and this is CD. If the intersection happens outside by extension here, then also the same rule, AM times MB. So exactly that's what is happening in this case. This is the intersection M. Let's call these 2 points as A and B, A here and B here. And let's call these 2 points as C and D, right? So we have 2 times 12, right? AM times MB is 2 times 12, is MC times MD or CM times MD, CM times MD. Okay, so far so good, all of you. Now, one other information is given. The same circle cuts the y-axis at 2 points separated by 2 units. Meaning, let's say this point is, let's call this point is 0, small c. And therefore, this point is 0, c plus 2. Okay. Now, I'm assuming this to be in the first quadrant. First, let's do with this, and then we'll do how to do it if it's the fourth quadrant. So for now, the picture is clear, right? Assuming it's in the first quadrant. So now, what is CM? CM is small c, and what is MD, which is c plus 2. So we have 24 equal to c into c plus 2. Either we can solve this quadratic. I'll pause here. So far, is this clear? Are you clear so far? Using the property. Anyone is not clear so far, please pause so that I can explain so far. All good? Okay, so from this point, I can either guess my C, 2 numbers which are apart by 2, such that the product is 24, it has to be 4 and 6. Or I can just solve the quadratic. I can expand as c square plus 2c minus 24 equal to 0. And then I can do factorization c plus 6 times c minus 4. And then say c is in the top portion, therefore c is positive, therefore c is 4, and c plus 2 is 6. So the coordinates would be 0, 4 and 0, 6. Right? So 4 times 6 is 24, 2 times 12 is also 24. But the question is, if P is given to be in the fourth quadrant, so had it been in the first quadrant like this, then the center of the circle won't be the average of A and B. So whoever said average of A and B are partially right. This portion will be half of the x coordinate. So the average of 2 and 12 would be 12 plus 2, 24 divided by, so 12 plus 2 divided by 2 is 7. And this center would be average of your 6 and 4, right? We got 6 and 4 here. I'll just say this is 6 and this is 4. I'll erase this. So this coordinate is 6. When I say 6, I mean 0, 6. And this coordinate is 4. It's not drawn to scale, but so this is, so average of 4 and 6 is 5. So the y coordinate of this will be 5. The x coordinate of this will come from this guy. So 7, 5 will be the center of the circle. So why is that? Because we know that when I draw a perpendicular from the center of the circle, it'll bisect and be perpendicular, right? Similarly, if I draw a line from the center, it'll bisect as well as be perpendicular. So the coordinates has to match with 7, 5. Right? Now, the only difference is now the circle is given to be the fourth quadrant. So instead of all the action happening up, the action is happening down. By that, what do I mean? So let me just draw the coordinate and circle again. So I'll just draw the circle. So I'll draw the circle here. And the coordinate axis. So It's here. And here. Okay, so this is what happened here. Okay, so this is my 2, 0. This is my 12, 0. And let's say this is my negative coordinate. Let's say this is negative C, and this is a further negative C minus 2, right? Minus C minus 2. Assuming C is a positive number, which is why I've called negative C. So C itself is a positive number. So negative C is a negative number, negative C and negative C minus 2. If you do that, then we'll get the same results. This will become -4 and this will become -6, because the same thing, 2 times 12 has to match minus C times minus C minus 2. So the minus and minus can go away. So this is C times C plus 2. So we'll get C to be 4, which means the coordinates of this is 0, -4, and the coordinate of this point is 0, -6. Right? And therefore, this center will be at -5. 0, -5. Therefore, the center of the circle will be, if you put halfway through this and halfway through this, 7, -5. Okay, agree. It's not an easy question, but did you have the knowledge to solve it? I think yes, because the only concept that we had to do, the main concept we had to do was the intersection of the chords in a circle, which we went over last class. Veer, is this clear to you? Is this working clear to you,
Yes,
Veer?
sir. Yes, sir.
Suhani, make sense? Is anyone not
Oh,
clear?
yes, sir.
Arab, you're okay? Okay.
Sir, I have one question.
Yes, please, you go ahead.
How can the center of the circle be in the first quadrant?
No.
Solve-
I started off just for explaining. I started off in the first quadrant, but the given question is the center of the circle is in the fourth quadrant. So, sorry, what? Please repeat your question, Yuvam.
Wait, so if you solve the quadratic equation, why would you get the first quadrant?
Why would I not get the first quadrant?
So you could have gotten like any quadrant. Why should you get the first quadrant?
No, I drew the diagram assuming it's the first quadrant, in which case I labeled these points as 0, C and 0, C plus 2. Assuming it's the first quadrant, I solved it just to show how to work it out, right? With positive number, it's easier, right?
Yeah.
And then I said, the given question says the circle is not in the first quadrant, but in the fourth quadrant, which means the circle has to be down below like this, intersecting the y-axis in negative coordinates, right? Which is why I said negative C and negative C minus 2.
Okay.
Sure.
Correct. Yeah, got it.
Makes sense,
Yeah,
right? Okay, good. Cool. Okay, so the first part is that. Now, second one, if the circle is divided into 4 equal parts by vertical and horizontal lines through P, find the perimeter of each quarter circle. So this should be easy. Now, first, let's find the radius of the circle. So the radius of a circle. Okay, so what is the radius of the circle? Okay. So to find the radius of the circle, I can connect it with, let's go back to this question. It's in here itself, right? So this was 7, -5. This is 2, 0. So let's find the distance between this point and this point. Okay. Actually, distance from the center to any of the points. I just happen to choose this one. How do we find distance between any 2 points? We know the distance formula, right? So if someone does not know the distance formula, here it is. For finding the distance between any 2 points, it's square root of x2 minus x1 whole square plus y2 minus y1 whole square. All of you know this? Ranveer, you know this distance formula for finding distance between any 2 points, x1, y1 and x2, y2? Or you have not seen this before?
No, sir, I think
Sorry, say that again, Ranveer.
I have. I don't use, I don't know, I think I have.
Okay, so in this case, let's apply. So x1, y1 is 2, 0. x2, y2 is 7, -5. So I want to find the distance between the center P and where it cuts the x-axis here at A. So square root of 7 minus 2 whole square plus 0 minus 5 minus 0 whole square. So it becomes 5 square plus 5 square. So 2 times 5 square, right? So the reason I'm writing it this way is so that you know you don't have to simplify. You can directly write 5 times root 2. 5 square can come out as 5 and then root 2. So 5 root 2 becomes the radius of the circle. Okay, now I can use the distance formula between any 2 points. In fact, let's intentionally use distance formula between this point and this point. So this is 0, minus 6, right? So let's try to get the same answer. If you find the distance between the center and this, right? So we have 7, minus 5 on one hand and 0, minus 6 on the other hand. If you find the distance formula, it gives square root of 7 square plus the difference between them is 1 or minus 1, doesn't matter. Anyway, it's getting squared. So square root of 50, which is the same square root of 25 times 2, which is 5 root 2. So obviously, if you have done the problem correctly, the distance from the center to each of these vertices A, B, C, D should be same. So we got 5 root 2. Does it make sense? Yeah. Okay. So now we find the radius. Now, what is the question? What is the perimeter of each of the quarter circles? So each quarter circle, the perimeter is not just 1/4 of the 2 pi r. That's one portion. You also have to add the radius here and the radius here. So the perimeter is 2r plus 1/4 of 2 pi r, which is pi by 2 times r. So in this case, r is 5 root 2. So we can just say 5 root 2. I can take r outside. 5 root 2 times 2 plus pi by 2. That becomes the perimeter of each of the quarter circles. Make sense? Arav, you're okay? Arav, I cannot see your full face. Maybe can you shift your monitor so that I can see your full face? Yeah, that's better. Veer, you're okay on this one? With the explanation? Okay. Yeah. Or if you can just put your electronic thumbs up also. Sometimes I'm not able to see fully clearly. It's sometimes dark. Okay, so that was the second part. Third part. If an equilateral triangle tangentially encloses the circle, find its area. Okay. Again, we have done this, but you just have to apply it, right? So equilateral triangle tangentially encloses the circle. So how will that be? So let's erase. In fact, I'll draw a new page, new circle. Okay, so this is the circle, and then we've had some intersection points with x-axis, y-axis. So it was 2 and 12 here somewhere. Okay, and then we had -4 and -6, something like this. I mean, I've not drawn to scale. Okay. So this is -4, and this is -6. This is 2, and this is 12. Okay. Now, if I have a tangent, that goes around this, right? So first I have to find out what is the question? If an equilateral triangle tangentially encloses the circle, find its area. Okay. So we know that if I have a circle within a triangle, the radius of the incircle is delta upon S, right? Where S is the semi-perimeter of the triangle and delta is the area of the triangle. Now, in this case, it's an equilateral triangle. For an equilateral triangle, what is the area? √3/4 times side square. I'm calling x as the side. √3/4 times x square is the side length, is the area, and the semi-perimeter is x plus x plus x divided by 2. So this is x, this is x, this is x, and this is my r. So this is 3x by 2. So what does this simplify to? So √3/4 x square into 2 by 3x. So let's cancel some things. So this is 2. So this is x. So this is root 3x upon 6. Now this is the radius of the incircle. But we already calculated this in the previous step was 5 root 2. So we already calculated this in the previous step was 5 root 2. And therefore we know x, the side length. So it will be 5 into 6 root, sorry. Okay, 5 root 2 into 6. Okay, fine. 5 into 6 root 2 by root 3. Okay, that's the side length of the equilateral triangle. But the question is, what is the area? Is it? Find its area. The equilateral triangle encloses the circle. So find its area. So we just have to say delta, which is the area, is root 3 by 4 times side square. So this quantity whole square, right? So which is 30 root 2 by root 3 whole square. So yes, some weird numbers, but that's fine, right? It's still numbers, right? So 900 times 2 by 3. So we can simplify this. I'll leave the simplification, not a big deal, right? So this is 300. 300 divided by 4 is 75. So it's 150 root 3. Yeah. Did anyone get this one? Or probably not, because they're all connected parts, right? Unless you get the circle radius, you won't be able to get this part. But is this clear right now? Sanvi, you're with me completely? Makes sense, right? Will you be able to do this on your own after class, let's say, right? Later tomorrow, if you approach the same problem. Yeah. Okay. And in fact, you guys should do that, right? So you've given a try, you didn't get it. We have discussed it now. Take a break after 2 days so that the memory is not there. So if you've really understood, you should be able to do it now. If you do it immediately after class, you'll be having the memory from the class itself, right? And therefore, it won't be a good test whether you actually understood. If you do it 2 days later, when you've forgotten, then only if you know the concept well, you would be able to do it again. Okay, but please do that. Okay, that was question 3. Sorry, that's only 3 parts of the question. 5C. 5D. A tangent to the circle from the origin touches the circle at T. Okay, find the perimeter of OPT. Okay, find the perimeter of OPT in such and such a form, right? So let's do this. So this is tangent to the circle from. So let me just paste this question again here so that you don't have to scroll back and forth. Tangent to the circle from O touches the circle at T. So this is, we have the circle. We know the radius of the circle is 5 root 2. That's what matters for now. And then the tangent okay. Now the coordinates of the center of the circle was 7, minus 5, if you recall. So I've not drawn it like to scale or exactly where each of those points fall, but this is 0, 0. This is origin. This is 7, minus 5, right? And we remember that there were, okay, all right, we can in fact use this guy itself, right? Why should we? Sorry, let's use the triangle itself. So this was the circle and origin was here. And then this vertical line came here. So this was that O. This is 2, 12, minus 4, minus 6. And this is origin, which is O. Now, this is P, which is the center of circle, which is 7, minus 5. Now I have a tangent from O to the circle. So let's say the tangent goes like this. So tangent graces through the circle here like this, right? Graces the circle like this. Now the question says, if the tangent from O touches the circle at T, so this is my T. Now I want the perimeter of the triangle OTP. So this is T. This is P. Okay, so the diagram is clear to everyone. Okay, now what? So to find the perimeter of OPT, we need three things, right? We need OP, we need PT, and we need OT itself. PT we know. PT is the radius, which we found out in the very first step. Not first step, one of the previous parts was 5√2. So PT was 5√2. And OT is yet to be found out. OP we can find out, right? OP is just, we know the coordinates of this is 0, 0. By distance formula, we can find OP, right? OP is how much? So square root of 7 minus 0 square plus minus 5 minus 0 square, right? I'm just being explicit. O is just the origin. So it's 7 square plus 5 square essentially. So square root of 49 plus 25, which is square root of, how much is this? 74, right? 74. So OP is square root of 74. So now we can use Pythagoras theorem to find the other one, right? So this is square root of 74. And this is 5√2. Okay, so OT square plus TP square is OP square. So we know that OP square is 74. 5√2 square is 50 plus the remaining part is OT square. So OT is square root of 24. Now the perimeter is the sum of these three parts, right? I'm expecting the perimeter in the form M root A plus N root B plus root C. So all of these are just some irrational numbers, right? So let's write out what is the perimeter that we have. We know one part is root 74. We know one part is root of 24 and one part is 5√2. And let's try to take out as much common as possible. From 24, 24 is 4 times 6, right? So this comes out as 2√6. So this is 2√6. This is 5√2. And root 74, I cannot take any perfect square outside. Now, what is this part saying? Find the integers m and abc if it's given that 1 less than m less than n. So if I have to match with this, if I have to match this pattern with this pattern, then I can see if m has to be less than n, then 2√6 is my m root a, because m is given to be less than n. And then 5√2 is my n root b. And then root c is my root 74. So I've identified all the letters to the corresponding numbers. M is 2, N is 5, A is 6, B is 2, C is 74. Now, what is all this extra nonsense here? 1 less than M less than N is fine. And A, B, C do not have any perfect square as a factor other than 1, which means A, B, and C cannot be further simplified outside the root. For example, one could argue that I could have left square root of 24 as 1 times root 24. But 24 has a perfect square as a factor of it, right? It's 4 times 6. So which means it's another way of saying simplify as much as possible by taking any perfect square outside the root. So 24 was 4 into 6. Therefore, I could take square root of 4 outside as 2 times root 6. 6 itself does not have a perfect square, which is a factor. If it did, then even that would come outside the root. So all of this extra stuff is saying simplify the square roots. That's all it's saying. Now, if you read the question again, all of this will make sense. Find the perimeter of OPT, which can be represented as sum of some 3 numbers. There are 3 lengths to a triangle. Each of them happens to be some irrational number. Find the integers m and abc, where 1 less than m less than n. So between this and this, I don't know which is m root a and which is n root b, unless I say the order m is less than n. And then ABC do not have any perfect square as factor other than 1. Okay, so on the face of it, it will seem very daunting. But if you dissect each part, it's not very complicated. Okay, does it make sense, guys? Ivam, you're okay? Arav, all of you, Suhani? You think okay? Honestly, you think you can do the same question 3 days from now? Let's ask Arav. You'll be able to do this question, Arav, 3 days from now.
Yeah.
Okay, you understood all the concepts, right, Arav? I want everyone. Veer, you're feeling confident as well?
Yes, sir.
The circle
Mostly.
intersection of the chords and all that.
Yes.
Okay, cool. All right, let's go to the next part, next question. which is question 4. Ym is the altitude of the hypotenuse. Let me just paste it here. Ym is the altitude of the hypotenuse in the right triangle, xyz. Triangle YMZ is smaller than the. Okay, let's first draw this triangle. Just 1 second. Sorry, was just drinking something. Okay. Right triangle XYZ. Ym is the altitude. So let's draw the right triangle XYZ. Okay. Did anyone get an answer on this before we start discussing?
Sir, I got one.
Yes, go ahead, please. What did you get?
Sir, I'm not sure of my answer.
That's fine. That's fine. No one is sure. Tell me.
Sides of xyz equals to 2 root 3, comma 3 plus root 2, comma root 5.
Okay. 2, 3 plus root 2 and
No,
root 5.
2 root 3.
Oh, okay. 2 root 3. Okay.
Uh,
Go ahead. 2 root 3.
comma 3 plus root 2.
3 plus root 2.
Yeah, and then root 5. Yeah, correct.
Okay. All right. Does anyone else get something similar? Suhani, did you get something like this?
No, I didn't get the question.
Okay. I mean, did you try enough? Try hard enough? I'm putting Suhani
Yeah,
on the
but
spot, but it's really a
I-
question for everyone. Did you guys try hard enough? Veer, what about you? What did you get?
So I managed to get to a certain point, but then everything went wrong.
Okay. All right. My message is same, guys, for everyone. Try hard enough, right? You should really struggle. Give your blood and sweat on this. Okay, let's discuss. Okay, so this is Ym is the altitude to the hypotenuse, right? So which means xz is the hypotenuse, right? Because Ym is the altitude. So this is y, this is z. This is, sorry, this is y. The center, the right triangle is y, right angle. Ymz is smaller in area than triangle YMX. So the way I have drawn, YMZ is larger. So I'll just switch. That's it. When I draw the triangle, I don't know how it is. So I'll switch. I'll say this is Z and this is X. That's all. And then I'll draw the altitude here. So this is YM. Okay. Okay. So this diagram is very clear to everyone, right? And we discussed this in the last class. When you have a perpendicular drawn from the right angle in a right angle triangle, it divides the triangle into 3 similar triangles: the big triangle, the small triangle, and the medium triangle. Why are all 3 similar? Because all of them have the same set of angles: theta, 90 minus theta, and 90. For example, if I start with, say, this is theta, this is 90 minus theta, right? Therefore, this is theta, and therefore this is 90 minus theta. So each triangle has theta, 90 minus theta, and 90. Therefore, all the 3 triangles are similar. So I'm going to call the triangles as small, medium, and large. The large being the XYZ, the small being the YMZ, which is the smallest one. It's given, right? YMZ is smaller in area than YMX. Okay, diagram is clear now. The sides of triangle YMZ are square roots of 3 consecutive prime numbers. Okay, Yuvam, how did he proceed from here? 3 consecutive prime numbers.
So I just took like 3 consecutive prime numbers and tried it with that. And
Okay.
so I took 2, 3, and 5.
Okay. So
root 3, root 2, and then root 5.
okay. So he took the sides as root 2, root 3, and root 5. Okay. So my question is, could it be that they are square roots of some other 3 consecutive prime numbers? Or that's not possible at all?
So no, that's not possible because according to the Pythagoras theorem, a square plus b square c square, so 2 plus 3 is 5.
That is fine. But maybe there's some other prime number in the future, some big number prime, and some q and some r, which are 3 consecutive prime numbers. So, right? And it could be possible that p plus q is r, no? I mean, p, q, and r are prime. When you square root p, I get p. When I square root q, I get q. When I square root r, I get r. So p plus q could be r, no? Would that not be okay?
I don't know, sir.
Okay, question for everyone. Okay, so he's guessing that prime numbers are 2, 3, and 5. Okay, Suhani, what do you think? Why can't it be some other 3 prime numbers which are consecutive? P, Q, and R are consecutive prime numbers. Root P, root Q, and root R.
I feel like it could be, but I don't know like exactly what the numbers are.
Then he is right. It cannot be. So 2, 3, 5 is the only solution. But I
Okay.
want you guys to think now and say, why is that the only solution? Can all of you think for a second, for 30 seconds? Why is no other set of 3 prime numbers not possible?
If the numbers are much bigger, then it's not possible that the squares of 2 of them would add up to the third one, right?
No, I'm saying the square roots, right? So maybe I'm just saying 71 and 73, and let's say the next prime number is whatever, I don't know, in the 90s, maybe 97, right? So in this case, it does not work out. But arguably, square root of 71 square plus square root of 73 squares could be a square root of 97 square, right? 71 plus 73 could be 97, right? Which in this case is not, but arguably it could be, right? Do you agree with me, Sanvi? Yeah, you're partially right, but you're not calling out the exact phrase I'm looking at.
Wait, is it because 2 is the only even number, so it's like the only one that can be consecutive?
Can you elaborate a little bit on it?
Like, in like prime numbers, there's no even because it goes even, odd. So like it wouldn't be consecutive because 2 is the only even number.
2 is the even number. What do you mean by primes are even, odd, even, odd? I didn't understand that.
Oh yeah, like it can't be consecutive because like I don't know how to explain it.
You are on the right track, but
Sir,
I'm
can
not-
I think I
Go ahead.
got.
Go ahead, Vyom.
Sir, it's because 2 is the only even prime number.
Agreed.
So if you take any other 2 odd numbers, any odd number plus any odd number is always an even number. So
Perfect.
and any other even number is not a prime number except 2. So it has to be 2 in one of them. So if you take 2, then you have to take 3 because it's consecutive, and then you get 5.
Excellently explained. Yes, that's exactly the logic, right? So that's why I'll repeat again what he said, if it's not clear to everyone, right? So we are starting with no assumption. We are saying P, Q, and R are 3 consecutive prime numbers. Therefore, the side lengths are root P, root Q, and root R, which means when I square, I should get P plus Q equal to R. But typically, prime numbers are odd, except for even. So odd plus odd will be even. So how can R be a prime number and be even? It's not possible, right? The only exception to that is we start off with 2, right? 2 being a prime number, which is even as well. And 3 and 5. It just so happens that 2 plus 3 is 5. That's how I phrased it this way. So root 2 square plus root 3 square is root 5 square. Does it make sense to everyone? In other words, if you have sum of 2 odd numbers, it has to be even. It can never be prime. The third one will never be prime, right? If I have 71 plus 73, which is why 71 plus 73 was an even number. It can no way be 97. Even if the next prime number is 137, it will be odd, not even. Sanvi, are you with me on this?
Yeah.
Yeah, makes sense. Therefore, 2, 3, 5 is the 3 consecutive, right? I'll erase this. So find the side lengths of X, Y, Z. So we found the side lengths of YMZ. So let's mark based on look, we can see which is the smallest, right? The side opposite to Y will be the smallest here. So this will be root 2, this will be root 3, and this will be root 5. And now it's just a question of similarity, right? So let's come to the medium triangle. Find the side lengths of X, Y, Z is the main question. So we can directly go for X, Y, Z. So X, Y, Z versus the small triangle YMZ. So root 2, so I'll say root 2, root 3, and root 5, right? So this is the small triangle. Okay, and this is the big triangle. In the big triangle, I know that root 5 is the smallest side. So this corresponds to root 5. So this is the small triangle, this is a big triangle, and this is the side lengths. This is the side lengths. So small, medium, large. These are sides, right? So the root 2 corresponds to root 5, which means the ratio, the similarity ratio is root 2 is to root 5. So once you know root 2 is to root 5, so this guy, so root 3 is which one? Root 3 is ym. So the one corresponds to ym. So this is ym, right? So in fact, I'll write out the three sides so that it's clear to everyone. So this is zm. And this is ym. And this is yz. Okay. So the corresponding one, the small in the big triangle, the small side would be yz. And in the corresponding side for the medium in the big triangle would be yx. And this will be xz. Right? Are all of you with me on this? The correspondence, everything is okay. So we know the ratio is root 2 is to root 5. Therefore, we can find this easily, right? So let's say yx upon root 3 should match 5. Right? Therefore, yx is root 15 upon root 2. Okay. And similarly, let's say this is xz. So xz upon root 5 is root 5 upon root 2. So I'm saying xz upon root 5 is root 5 upon root 2 by just correspondence. Therefore, xz is 5 upon root 2. So the three side lengths of the big triangle are 5 upon root 2, 15 upon root 2, and root 5 itself. So I can, of course, take the root to the top. All that manipulation I can do. But after having come this far, why did you mess up on the side length somehow? What happened?
Wait, sir, I didn't do it this way after that.
Okay, what did you do? Tell me. But okay, before you go on to that, is this clear to everyone? How using similarity of triangles and finding the corresponding side lengths, I can find the ratio, I can find the side lengths. Everyone clear on this one? Ranveer, you're okay? Makes sense, Ranveer? Okay, all right. Yuvam, go ahead. What did you do? After finding, I thought that was the hard part. Finding the side lengths root 2, root 3, root 5 was the hard part. After that, it should be simple. Go ahead.
Sir, I thought that the big triangle was a
It may be, it may not be. Why do we even care? In fact, it is not, because if it is 30-60, I expect the ratio to be 1 is to root 3 is to 2. I know the ratio is root 2 is to root 3 is to root 5. You know that, in fact. And that's not same as 1 is to root 3 is to 2, right? Therefore, it's not 30-60-90. But even if 30-60-90, so be it. Let the number speak for itself. Right? So similarity is how you'll be able to find the side lengths.
correct.
Okay. Veer, you're okay on this one? Convinced?
So,
Yeah, Veer, I could not hear you. Or
yes, sir.
either electronic
Can you hear me
comes
now?
up or something. Okay.
Yes, sir.
I can see you are unmuting, but I cannot hear you, Veer. Either electronically give a thumbs up, guys, or just unmute, call it out, and then mute. Okay, I'm assuming all okay. Otherwise, I'll hear otherwise. Okay, all right. That's question 4. We ended up taking a lot of time on this discussion. That's fine. It's worth it. Question 5, trapezium. Yes, Veer, you had a question. Go ahead, Veer.
No, sir, I was just saying that I can solve this one.
Yeah.
So I was just saying that I can solve this one.
Oh, okay. All right. Sounds good. Let's see. I'll just go for space here. Yeah, Veer, call out. What did you get on this one?
So I got 4 plus 4
Sorry,
root 2
Go ahead.
is to 6 root 3.
Please repeat again. I didn't hear you fully.
4 plus 4 root 2 is to 6 root 3.
Okay. Like this. Okay. If at all this is the answer, I would have expected you to simplify one more step, right? I can divide throughout by 2 and say 2 plus 2 root 2 is to 3 root 3.
Yes, sir.
Okay. Okay, I'll block this and keep as your answer. Anyone's answer matches with Veer's? Anyone, Sanvi, did you do this?
No, I didn't get this one.
Okay. Anyone get this to contend this answer or agree with this?
So I have a different answer, but I think it's wrong.
Call it out, please. It's fine. Call it out.
I got x square brackets √2 plus 1 over √2 raised to
Sorry, what is x? What is x in this case?
So yes, that was my issue.
Okay, yeah, there is no x at all, right? I mean, then finally
I
it should be
said-
numbers.
Yeah, I set something as x, but I'm not sure why I was getting it in the answer.
Okay, all right. So let's discuss. So isosceles ABCD has top side AB equal to the two sides, two legs AD and BC. And likewise for another isosceles triangle PQRS, which means both of them are looking something like this, right? So maybe one is looking steeper like this, right? And the side lengths are same. Okay, now I'll draw a better diagram, but obviously in geometry problems, you cannot expect the perfect diagram in the first round. First draw a sketchy diagram and then come back and based on the data given in the problem, redraw. Okay, AB is given to be PQ. So this is ABCD and this is PQRS. Both of them are isosceles trapeziums. And in one of them, the base angle D measures 45 degrees. This measures 45, therefore so is this. While in the other one, base angle S measures 30 degrees. So I definitely have to redraw because this looks more like 60 degrees. So now I'll draw a better diagram. After drawing the first cut, I'll draw a better second cut. So here's my ABCD. So AB, right? This is 45. Again, you don't have to like take too much trouble, but roughly to scale would be good. And then PQRS, I'll draw it in this. So this is PQ and this base angle is 30 degrees, right? So it'll be much steeper like this. Much shallower, I mean. Okay, so this is PQRS. PQRS. Now, all of these side lengths are given to be equal. This is equal to this, equal to this. Similarly, in this triangle, ABCD, this is given to be equal to this, equal to this. And further, AB and PQ are also given to be equal. So let's call all of these quantities as X. So this is X, 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 X. Okay. Now, what is the question? This is 30 degrees. This is 30 degrees, and this is 45 degrees. The question is, find the ratio of the two areas. That's it, right? In terms of √2 and √3 and as simplified as possible. Okay, so very simple. All we have to do is find the height and the base in each of these cases. So if I draw a height here, right? So this becomes a 45, 45, 90 triangle. So let's say this is, I'll call this point as some M or something, doesn't matter. So AM by AD is 1:√2, right? So we know this. Therefore, this would be X upon √2. And therefore, this also will be X upon √2. Similarly, if I have, so this will also be X upon √2, and this is X. Okay, so now we know that area of a trapezium. Okay, let's complete the other diagram and then come back. So same thing here. I'll draw the height.
So how did you get 1 upon √2?
Because in a 45, 45, 90, the ratio of the three sides is 1:1:√2, right?
Yeah, okay.
So the √2 corresponds to X. Therefore, the 1 will correspond to X upon √2. Yeah. Okay. And similarly, this is a 30, 60, 90. Since Yom has been looking for a 30, 60, 90, here you go, Yom. So this is X by 2. 1:√3:2, right? That's your 1:√3:2 here. So this is X by 2 because it corresponds to one part. And this is X by 2 times √3. And this is X. Okay. Now, what is the ratio of the areas? So area is what? Area of a trapezium is height times average of the two bases. Let's say the bases are A and B, average of two bases. We just have to apply it and not do silly mistakes. That's it, right? So in the first one, X by √2 is the height. Okay. And the two side lengths are X at the top and X plus X by √2 plus X by √2, right? So X by √2 plus X by √2 whole divided by 2. So that's one area. And the other area is same thing. The height is X by 2 and the average of the two bases. The top base is just X and the bottom is X plus x root 3 by 2, x root 3 by 2. I'll just say x root 3 because it's appearing twice, right? X root 3 by 2 into 2. So this is just this upon 2. Okay. So now we can just try to cancel off unnecessary stuff. This 2 cancels off with this 2. This x cancels off with this x. So, and this x by root 2 plus x by root 2 is nothing but 2 times x by root 2. So I'll replace this with 2 times x by root 2. 2 times x by root 2 can be further written as x root 2. I can write this as x root 2. So ultimately, how many x's do I have here? I have x times 2 plus root 2. Okay, upon root 2. And here I have, how many x's do I have? I have 2 plus root 3, I think, right? 2 plus root 3. If I'm doing some silly mistake, please call out, guys. I'm doing this also now with you. I could be doing mistakes as well. Okay, upon 2. This is x, right? X also gets cancelled. This also has x. This also has x. So the final ratio is this. Now I can cancel off 1 root 2 here, and I can multiply the root 2 upper. So it becomes, if I bring this root 2 to this side, it becomes 2 root 2 plus 2. And then this becomes 2 plus root 3. Is that what he had? Let's see. 2 plus 2 root 2 and 2 plus root 3. Almost close. 2 plus 2 root 2 was there. But somehow on the second part, you have 3 root 3, Veer. I am getting 2 plus root 3. Can you check? Did you find any mistake in yours? Or did you find any mistake in what I did? Veer, if you're with me.
I'm checking right now, yeah.
Okay, all right. If you don't find your mistake, you can do it later also. But conceptually, it's very simple, guys, right? 30, 60, 90, you should be able to figure out any side length. 45, 45, 90, you should be able to figure out any side length, given you know one side. That's the main idea. Area of a trapezium, you guys should know. Those are the 3 main things. Okay, all good. Sorry, Sanvi, I thought this was a fairly straightforward question, right? I'm picking on you, but you could have done this, right? What is the problem here? Or Suhana, what about you?
So for me, I thought I was doing it wrong when I got to like the second part.
Okay, Suhani, how about you?
Yeah, I got to the like drawing out the diagrams, but I think I made a problem in the like actual calculation part.
Okay. All right. Okay, fine. Like I said, like go back and do all the problems, guys. If you've done something and already got the correct answer, that's fine. You can skip that. But anywhere you didn't get a correct answer, or you didn't know how to do, or stuck halfway, or did a silly mistake, redo. That's the best way to make sure that you've really understood. Okay, let's move on to a new topic. I'll pause here for a few seconds. Any questions that people want to ask? General questions from today discussion or anything else from geometry? Arya, you're okay? I didn't ask you too much today, but you've been very quiet. All okay?
Yeah, it's fine.
Okay. So the plan was go back to algebra and number theory and complete a few things. So let me just open up. So we did in algebra, we did rates and speed, fractions, percentage, all that we did. We did not cover arithmetic progression and geometric progression. I'll do that right now. And then we'll go on to some number theory in factorization, HCF, LCM, all that. Okay. So arithmetic progression and geometric progression. We did not do arithmetic progression and geometric progression, if I recall. Right? Maybe I did it in the demo class, but let's do it now properly. Okay. So arithmetic progression is when you have arithmetic progression. Arithmetic progression, also known as AP. When numbers are uniformly spaced apart. Let's say you have 2, 5, 8, 11, right? 14. You're uniformly spaced apart. That's such a sequence is called arithmetic progression or arithmetic sequence. Progression, sequence all mean same thing. Series. Okay. Now, typically, what do we want to find in this case? What is the 78th term? Right? So it doesn't make sense to write out all the terms if you can quickly find out a way to find the 78th term. So what is it? Each is a hop. You have a additive hop of +3, +3, +3, and so on. And to reach the 5th term, you had to take 4 hops, right? From the first term to reach the 5th term, you have to take 4 hops. So to reach the 78th term, I would take 77 hops, one less than the term itself. And each hop is of size 3, and I'm starting off with 2. So that gives me the 78th term. So 2 plus 77 hops, each of size 3, right? So that gives the 78th term. And typically this is denoted by U suffix 78. U stands for, or T suffix 78. It denotes the term number. So 78th term, or the 78th term is typically denoted as with a T or a U. So more generally, if I have to say what is the nth term, I'll just call it UN. Okay, you have, for any arithmetic progression, you have a starting term, which is called A. And then you have a common difference, which is D, right? The additive hop that you're traveling. So there are only 2 parameters to an arithmetic progression. What is your starting term and what is your additive hop? Plus, 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 so on, right? It could be a negative number also, by the way. In this case, it's a positive 3. Let's discuss that also. So it's A plus, to reach the nth term, we saw that we need n-1 hops, and each hop is of size D. So this gives the formula for the nth term. Let's check. Suppose we wanted to use this formula to find the 5th term. According to this, it would have been 2 plus 5 minus 1 into 3. So it should have been 2 plus 12, which is 14. And sure enough, we had the 5th term as 14. Okay, so that's finding nth term. The other typical thing that you want to do is, what is the sum of the first 23 terms? I'm saying 23. It could be n terms. What is the sum of the first n terms? How do we do this? So this is also very much doable in an arithmetic progression, right? So let's say, suppose I have 2 plus 3, let's take the same sequence. Let's do the first 5 terms. So if I have 2 plus 5 plus 8 plus 11 plus 14. Now, if I write it in the reverse order, it's 14 plus 11 plus 8 plus 5 plus 2. So let's say call this as the sum S, right? S suffix 5, meaning sum of the first 5 terms. I've written the same sum in the reverse order. It has to be the same numerical value. Now, if I add both, I get 2 times S5 is 2 plus 14, which is 16, 5 plus 11, which is 16, 8 plus 8, which is 16, 11 plus 5, which is 16, and 14 plus 2, which is 16. It's not coincidence. It's because of the way the arithmetic progression is laid out, uniformly spaced. And when you write it in reverse, it compensates perfectly. So the smallest and the largest term add up to the same thing as the next smallest and the next largest, and so on, right? So now S5 just becomes, we have 5 pairs of each of them adding up to 16. Where did the 16 come from? The sum of the very first and the very last term, right? Divided by 2, right? So that's the sum of 5 terms. Now we can generalize, instead of 5 terms, suppose it's sum of n terms. What would we do? We have n pairs instead of 5 pairs in this example. And each pair adds up to what? The first term and the last term, U1 plus UN, and divide by 2. So now I can replace this, right? So n, I know the first term is nothing but A, and the nth term, or the last term, as we just saw, is A plus n-1 times D. So this was my UN, right? So it's A, which is the first term, A plus n-1 times D, which is the last term or the nth term. And then you plug it in here, you get this. Of course, I can write it as n times 2A plus n-1 times D, but I don't want to do that because that won't give us intuition. Let's keep it as A plus n-1 times D. That way, you know that as you're saying it out, you're talking about the first term, you're talking about the last term. This is U1 and this is UN. Okay, all clear so far? Ranveer, your video is off, beta. Turn on the video and just confirm all okay. Following along?
So my video's on.
Okay, now it is on, but it was not until I called out. Okay, anyway,
Okay.
maybe a glitch on my side. Sorry, apologies if that's the case. But all okay, Ranveer, you're able to follow along? Arithmetic progression? No, I cannot hear you if you're saying something, Ranveer. Okay, something messed up with the video or with your audio, but that's fine. Okay, let's go on. So the other important sequence is the geometric sequence or the geometric progression. okay, also known as GP. So in a GP, what happens? You start with some term, and then instead of additive hops, you have multiplicative hops. Let's say 2, 6, 18, 54, and 54 times 3 is how much? 162, and so on. Okay. Now here again, the same challenge. How do we find the nth term? Okay, let's find the fifth term. How did we find the fifth term? Exact same strategy. We had 4 hops, but each hop was a multiplicative 3. Multiply by 3, multiply by 3, multiply by 3. Therefore, we had to do 3 power 4 times. Why 4? 5 minus 1. To reach the fifth term, you had to hop 4 times. And you're starting off with 2. So it's 2 times 3 power 4. More generally, a geometric progression starts with a first number a, and then each successive term is a times r. R is the ratio, the common ratio. So multiply by r, multiply by r, multiply by r, and so on. So the nth term would just be a. Okay, in fact, I'll write out below this. Un is, instead of 2, I'm going to write a. Instead of 3, I'm going to write r, because that's the ratio by which you're multiplying. And then instead of 4, I'll write n minus 1. To reach the nth term, I need n minus 1 multiplicative hops. So that gives the nth term of a geometric progression. Let's check here. So in fact, we have it here, right? 2 times 3 power 4 is exactly what we got. 2 times 3 power 4 will be 162, the fifth term. Okay. Now, the other thing that we want to do in a geometric progression also is, what is the sum of the first 5 terms, or the sum of the first n terms? Okay, I'm not going to derive this expression. We can do it actually. But the interest of time, I'll just give you the. In fact, let's do it. It's worth doing it. Okay. So suppose I want to find the sum of the n terms in a geometric progression. How do you do it? So s suffix n means sum of the first n terms. So I'll write it as a plus ar square. Okay. All the way till the nth term will be ar power n minus 1. Okay. Now what I'll do is, I'll do a small trick here. I'll multiply this entire thing by r. So r times s suffix n. This is suffix, it's not s times n. It's suffix n, sum of n terms. So if I do r times sn, the first term becomes a times r. But instead of writing it here, I'll switch it lightly and then write it here. And in a second, you'll see why I do that. So I'll write ar here. The second term is ar square. I'll write it below this, and so on. The penultimate term will be ar power n minus 1, which will fall below this. And the last term will be ar power n. Okay. Now, if I subtract these two sequences, let's see what I get. I get Sn times 1 minus r equals. Here, you can see that this cancels to 0, this cancels to 0, this cancels to 0, like telescopic cancellation type of thing, right? Very similar. The only prevailing terms are the very first term and the very last term. Right? So the final result is a minus ar power n. So in other words, s suffix n is a times 1 minus r power n upon 1 minus r. Okay. So this gives the sum of n terms of a geometric progression. I can also write in the reverse way. I can subtract the second one minus the first one, in which case it'll be this. So exactly same, right? For example, if the ratio happens to be 3, then 1 minus 3 power 5 will be a negative number, but 1 minus 3 in the bottom will also be a negative number. Ultimately, both will get cancelled. So depending on whether the common ratio is more than 1 or less than 1, you could use one of the formula. By less than 1, I mean a geometric progression could be something like 8, 4, 2, 1, half, and so on. This is also a geometric progression where the ratio is half. Right? The ratio is always the latter by the former. So it's 4 divided by 8, 2 divided by 4, 1 divided by 2. The ratio is half in this case. Okay. Now, for geometric progression where the common ratio is less than 1, just 1 second. Let me switch on the light here. It's very dark here. 1 second. Yeah, sorry. So for a geometric progression where the common ratio is less than 1, there is another important result that you'll see, right? So for example, let's take the same sequence, 8, 4, 2, 1, half, 1/4, and so on. If you keep adding this till infinity, so 8 plus 4 plus 2 plus 1, all the way till, if you keep adding infinite terms, what is the sum that we'll get? Okay, rather than take infinite terms, let's say we take 1,000 terms, right? If you keep adding till 1,000 terms, what do we get? The first term is 8. Okay, and r is half, so it becomes half power 1,000 upon 1 minus half. Now, what is half power 1,000? Half power 1,000 is practically 0. If you keep multiplying half by itself 1,000 times, it's becoming very, very tiny number. So this is practically 0. So it just becomes 8 upon half, which is 16. Right? So in other words, the sum till infinite terms will just be a by 1 minus r. So sum till infinite terms will be a by 1 minus r, as long as r is numerically less than 1. Just 1 second. Sorry, guys, for the many interruptions today. Okay, so just to be clear, the last one. So sum till infinite terms in a geometric progression holds good if r is less than 1. Right? If r is less than 1, if r is numerically less than 1. So what do I mean by numerically less than 1? For example, if I have a geometric progression like this, let's say I start with 27 minus 9 plus 3 minus 1 plus 1/3 and so on. So here the ratio is minus 1/3. Even here I can find sum till infinite terms. So why is that? Because if I do sum till again same 1,000 terms, it'll be 27 times 1 minus, the ratio is 1 minus 1/3 power 1,000 upon 1 minus 1/3. But minus 1/3 power 1,000 by the same logic is a very, very tiny number, almost going to 0. So practically sum till 1,000 terms is sum till infinity. So which is just 27 by 1 minus 1/3, which is 27 by, how much is this? 4/3, right? So it will be 81 by 4. So if I add, you can see this, if I add a few terms, you'll approach 81 by 4 is approximately 20, right? Do we approach 20? Let's see. 27 minus 9 is 18. 18 plus 3 is 21. 21 minus 1 is 20. 20 plus 1/3 is only slightly more than 20. And then next one will be minus 1 by 9. You're seeing that we are almost zoning in on 20, right? Which is 81 by 4. So sum till infinite terms in a geometric progression is this. Okay, let's do one example problem. Okay, so let's say I have a square. Okay, I have a square here like this. Okay, and now I take the midpoints of each of them and I connect all the midpoints. So I connect the midpoints of this, midpoints of this. Okay, now again I take the midpoints of this one, I add all of this. Okay, and so on. Okay, so let me just do one more and then I'll tell you what the problem is. So I'll connect this midpoint here. This will be a square, this will be a square, this will be a square as well. Okay, now can you find what is the area? What is the sum of the let's actually keep it very simple. What is the sum of the areas of all the squares? So can you, for the first starters, find sum of areas of all the squares going till infinity, as in the same pattern keeps repeating, right? So I can take another smaller square and put it inside this, right? So you understand what's happening, right? So this is another square, and then within that there'll be another square. This pattern continues. And let's say I'm giving you the starting length of this square is 4 centimeters. Can you guys take a minute to do this, please? Okay, anyone has an answer? Veer, how's the progress?
So I'm working through it, but like, yeah.
Okay, I'll give you guys another 1 more minute. If anyone has an answer, you can call out, guys. Okay, they don't even have to prompt. Anyone can call out if you finished it. Arya, what is the side length of the second square? The outer square, green square is 4, is the side length. What is the side length of the second square?
I got 2 root 2.
2 root 2. Did everyone get 2 root 2? That part is easy, right? So this is, so he's saying this is 2 and this is 2. This is 2 and this is 2. Therefore, by 45, 45, 90, this should be 2 root 2. Okay. By the same logic, if I divide this into root 2 and root 2, right? This is root 2 and root 2. If I go one level below, then this one is root 2 times root 2, which is 2. And you can see this roughly, right? The blue side is half of the outer green side. Are you able to see this, all of you? So with every square down, it goes down by root 2. So the topmost side, the area is 4 square. The next one is 4 upon root 2, which is what the 2 root 2 is, square. The next one is 4 upon root 2 upon root 2, right? So in fact, I'll write 4 upon root 2 as 2 root 2. 4 upon root 2 is 2 root 2. So 2 root 2 square. The next one is 2 root 2 divided by root 2, which is 2. The side, the blue square is, the dark blue square is 2 square. The next one will have a side length of 2 upon root 2, which is root 2 square. So let's see what this pattern is. This is 16, and this is 8, this is 4, and this is 2, and so on. So it's a clearly geometric progression where the starting term is 16 and the common ratio is half. Therefore, sum of infinite terms would be a by 1 minus r, as we just saw. So it'll be 16 by a by 1 minus r. R is half in this case. So it'll approach 32. So sum of all the areas will be 32. Does it make sense, guys? All of you good on this? Okay. Now, I know we are up on time, but I just want to take a few more minutes. I just want to complete one concept on factorization. Due to a few disruptions, I had to go a little late. Okay. Now, suppose I have any number to go on factorization. Right. So any number, suppose I take 360, right? So it can be factorized into smaller parts. So let's say it's 18 into 20, and then I can split this 18 as 9 into 2, and split this as 3 into 3, and then likewise 10 into 2 and all that. Let's do that and see what we get. So we get how many 2s? Just correct me if I'm wrong, guys. So we have finally 3 2s. So it's 2 power 3, and then we have 2 3s, and then 1 5. Let's multiply and just check. 2 power 3 is 8. 8 times 9 is 72. 72 times 5 is 360. Okay. Now, suppose someone asks, how many factors does 360 have? It's a fairly elaborate process to write the factors. So how would I do it normally? I'll say, I'll start with 1. 1 times 360. I'll do it in pairs. 2 times 180. 3 times 120. If someone has to leave because of next class, please feel free to. My mistake of starting a little late, and then I'll just wrap in another 5 minutes max, right? 4 times 90 and so on, right? But it'll be a fairly elaborate process. And by the time we get 18 times 20, that's the last one, right? Why am I saying that's the last? I'm consciously making an effort to keep the smaller factor and bigger factor, that product. And 18 and 20, you've reached a limit where both are almost equal. The next one, 19 times 19, will be 361. Right now, but it's a fairly long process even for such a small number like 360. So, and I'm missing a lot of steps, right? 5 would be here, 6 would be here, 8 would be here, 10, 12, all that will appear here, right? Now, is there a more efficient way of finding number of factors? Because that's something we always want to do. If we take any number, we write it out as product of powers of prime numbers. That's called prime factorization. So prime factorization is not just writing it out as product of any 2 factors, but product of powers of prime numbers. For example, 360 is also 20 into 18, but that's not a prime factorization. I have to break it down to the lowest leaf. The leaves are nothing but prime numbers. So once you write it out in terms of prime numbers, counting the number of factors becomes easy. How does it become easy? Okay, so let's say this is 2 power 3 times 3 power 2 times 5 power 1. What does it mean? I have a bag of 2s. Let's say there are 3 2s here. Okay, I have a bag of 3s. There are 2 3s here. And then I have a bag of 5s. There's only 1 5 here because this is 2 power 3, 3 power 2, and 5 power 1. Now, what does it take for me to create a factor of 360? I can pluck a few 2s, I can pluck a few 3s, I can pluck a few 5s, I can combine them, and that will become a factor. For example, an example factor could be, I'll pluck all the 3 2s, I'll pluck no 3s, I'll pluck the 5, the single 5. That's a factor. 2 power 3 times 8 is whatever that number is, I don't care, but that's a factor. Another example, I can pick 1 2, I can pick 1 3, and no 5s at all. It's a factor. Another example, I can pick no 2s, no 3s, and no 5s. That's the number 1, which is a factor. I can pick all the 3 2s, all the 2 3s, and all the 1 5s. That's a factor. 360 is a factor of itself. So ultimately, I can mix and match however number of ways I can pluck from the 2 basket, from the 3 basket, and the 5 basket. Now, how many choices do I have in the 2 basket? I have 4 choices. Why 4? I could pick either 0 2s or 1 2 or 2 2s or 3 2s. So I have 4 choices. Similarly, when I go to the 3 basket, I have how many choices? I can pick either 0 3s or 1 3 or 2 3s. So I have 3 choices. When I go to the 5 basket, I have 2 choices. I could either pick 0 5s or 1 5. So where are these numbers 4, 3, and 2 coming? They are 1 more than the number of 2s available, 1 more than number of 3s available, 1 more than number of 5s available. So, and if I multiply all of this, that gives me the number of factors. 4 times 3 times 12. What is that? 4 times 3 times 2, which is 24. So if you look at the number 360, it has 24 factors, because I can plug any number of 2s with any number of 3s and with any number of 5s, and that combination will give me a unique factor. Does it make sense? Swani, are you with me? Yeah?
Yes, sir.
Okay. So in other words, if I write any number n as p power a times q power b times r power c, and let's say there were 3 of them, it could work for more, right? Where p, q, and r are prime numbers and a, b, c are exponents. The number of factors of n, f of n, meaning the number of factors, will be just a plus 1 times b plus 1 times c plus 1. And this is not just, I can have one more, right? The same pattern continues, d plus 1 and so on. And if a particular prime number is not even appearing, let's say 31 is a prime number, but it does not feature in here. That is also fine, because it will be 0 plus 1, which means you're multiplying with 1. Should not matter. So even if a prime number does not appear, the formula still holds good. The power is 0, therefore you're multiplying by 0 plus 1. There's no choice. You have to pick only 0 31s. Does it make sense? Okay, we'll stop here, but this is important. Factorization and counting number of factors. Okay, all right, we'll end it today, and then sorry for the disruptions, and we'll follow along next week. I'll give homeworks. Do the previous homeworks, guys. Homework 1, 2, and 3. Please just go back and redo all of them once more and get comfortable, right? Now is the time to build all the fundamentals strongly. Okay, bye.